Hello students, welcome to today's lesson. So for trigonometry, we're going to be looking at the very first section and we're going to learn about angles. So to begin with, let me get all set up and we'll start learning about angular measure and how we use that in trigonometry. Okay, so to begin with, I'm going to start off with some basic definitions. And so basically we're going to do an angle in standard position, all right? So probably earlier in your life you used a protractor, you measured, usually counterclockwise like this, angles going from 0 to 180 degrees halfway around a circle. In trigonometry, when we do an angle in standard position, we have an XY plane and the initial side is the x-axis. That's where the angle begins its measurement. And terminal side is where it terminates. So this angle would start here on the x-axis and then rotate counterclockwise until it got to that terminal side. So that angle right there looks like maybe it's around 130, 140 degrees, something like that, right? And then this is the vertex where that comes together. So basically an angle just has two rays that join in a common point called the vertex. And in standard position, that's at the point 0, 0, right? So these are kind of the characteristics. So you have the vertex at 0, 0, positive x-axis is the initial side, terminal side is the ray that terminates the measurement, and that should be angle, looks like. Okay, not angle, whatever that is. Okay, a circular arrow is drawn to indicate which direction it's measured. So we're going to measure this counterclockwise, so we have that circular arc like that. The other thing we typically do, you'll see a lot in trig and calculus and higher math, is we use Greek letters a lot to represent our variables. So in trig we use theta very commonly, and then alpha, beta, and gamma you'll use pretty commonly. All right, so what we're going to do is we're just going to sketch some angles. Now you don't have to have a protractor, you just sort of estimate these the best you can, but I'll show you what I want you to do in standard position. So what you do in standard position for each of these things is we're going to just draw out an XY axis on here, and then we'll go like this. All right, so the first thing I'm always going to do is I'm going to start with the labeling that initial side. All right, 45 degrees would be this way. We know from there to there is 90, so halfway between 0 and 90 is 45. So we draw that terminal ray like that. And then we do counterclockwise like that. That's your angle. I'll call that theta. Theta is 45 degrees, okay? The next one, we'd start the same way. We start with shading in the positive x-axis. This would be 90 degrees, 180. These things go by 90. So if that's 90 and that's 180, you're roughly kind of in this area here. So you draw that terminating ray like that. Then that would be your angle theta. That's equal to 150 degrees, like that. Okay, again, you're just estimating when you're doing that. So this little angle right there would be 30 degrees. So you're going 150 and 30 more would give you the 180 degrees. Okay, so that's how you do that in standard position. All right, so everybody okay with that? Okay, all right. All right, so the next thing we're going to look at on the second page is angles can be negative. Now, you may not have ever learned that before just because you haven't got to a point in math where you needed negative angles. So negative angles are necessary in physics and applications and graphing and stuff like that. The only difference is when you have a negative angle, you're just going clockwise. You still start at the positive x-axis, but that's how you're going to draw a negative angle then, okay? All right, so we'll sketch a couple of these things out here to begin with. So let's just sketch some more angles. I want to get this kind of out of the way. So I'm going to go ahead and just draw my x and y axis. You can just freehand this if you want to. I have a tool that's kind of nice that allows me to draw these pretty nicely. Okay, just kind of freehand that. And then we'll get started putting these angles together then. Okay, so what we'll do now is we always start with this. You always need to start at the x-axis. So go ahead and draw a ray on the x-axis and then count it out. Okay, this is a positive angle, therefore it's counterclockwise. So it'd be 90, 180 would be halfway around the circle. So you would just shade in the positive x-axis. So it'd go like that, and then your angle theta, I like to use theta a lot for an angle, is 180 degrees. Okay, we also call that a straight angle if it's 180 degrees. Okay, all right, 300 degrees. Again, it's a positive angle, so we know we go counterclockwise. So we shade this in, and again, count it out. Okay, go, that's 90, that's 180. This is 270. And then all the way around the circle's 360. So you're somewhere between 270 and 360. So you would end up being, if you do 270 plus 30, you get the 300. So you just sort of estimate a 30-degree angle from there to there. And then that gives you a good estimation for that angle. Then again, you have to put this arrow here. So we go counterclockwise like that. And then I'll just label that. That is theta is equal to 300 degrees, okay? Okay, now the next two, you start getting into negative angles here. So what we do here is, again, start with the x-axis. This time, since it's negative, you're going to go clockwise. So we count it out like this. So you would have negative 90, negative 180, negative 270. So you would end up there. And see, if you just give me this without that curved arrow, you're not really telling me which direction you're going in. So you start here, draw that curved arrow, and then you can label that as theta is negative 270 degrees. Okay, and the last one's negative 210. So we start here, count it out. Again, this is negative 90, negative 180. This is negative 270. So really, if you think about it, negative 180 plus negative 30 is negative 210. So you go halfway around the circle and then 30 more just to estimate, and then do your clockwise arrow, and then theta is labeled as negative 210 degrees. All right, so everything we do in trigonometry has something to do with an angle. All semester long, you'll be looking at angles in just about everything we do. So you want to know what we mean by standard position. Okay, so when I do these recordings, I like you to do a few problems here and there yourself. What I typically do on this is just pause my recording. I do this on Camtasia, and and then go ahead and pause, and once you're done, just check your answers then, okay? Okay, so if you got everything done, this is what you should have come up with. So 225 degrees is a counterclockwise angle, should be in this area. Again, this is 180 degrees there, this is 270, so you're actually halfway in the middle of 180 and 270. So you want to notice that 180 plus 45 is 225. That's how I know that I'm halfway in the middle. Then you're just estimating. Okay, part B is a negative angle, so you go clockwise. So your angle should have looked like that, x-axis, a terminal side like that. Number C is a negative angle, so again, clockwise. And then you would be in this region here. Notice on this, if you count it out, that's negative 90, negative 180, negative 270. And notice that negative 270 plus negative 45 is negative 315. So you're really halfway in the middle between the negative 270 and all the way around the circle. Okay, last one would look like this. It's a positive angle, so counterclockwise, and you would end up in this region. Again, this is 270 right in here. So notice that 270 plus 20 is 290. Okay, so that's how you do that. Okay, so I do want you to estimate, and get pretty accurate, but it doesn't have to be perfect. Okay, all right, so hopefully we're okay to start with that. Now, just a couple of definitions I want to go through. You probably have done all this in your background. So a 90-degree angle is called a right angle. Okay, a 180-degree angle is called a straight angle. Okay, acute angle is a small angle. That would be an angle that would be between 0 degrees and 90 degrees. Okay, something like 30 or 45, 89. If it's between 0 and 90, it's acute. An obtuse angle is a bigger angle that goes past 90 degrees. And what you have there, oh, hold on just a minute. Let me pause this. My pen is leaking. I never know what causes it to do this, but the only thing I can do is just reboot this. So I'm going to pause and get. Okay, let's see if the leak has been fixed. Okay, I have no idea why it does that, but it does that sometimes. Okay, so an obtuse angle is between 90 degrees and 180 degrees. Okay, now one thing I want to talk about is just a little bit an interval. From pre-calculus, college algebra, high school algebra, you learn about intervals. So whenever you use parentheses, that means the boundaries are open, so they don't include. And another thing is when you have brackets, that just means the boundaries of the interval are closed, and that just means that you do include that. So I want to just remind you of that. So an acute angle, we would say, well, it's between 0 and 90, but it does not include the endpoint, so we go like that. All right, 0 degrees is not an acute angle. 90 degrees is not an acute angle. And then obtuse, you would say parentheses 90 degrees, comma 180 degrees like that. So it's everything between 90 and 180, but it doesn't include the endpoints. Okay. All right, moving on, the next thing we'll talk about is what we mean by coterminal angles. Before I go through that, I want to kind of go through this, I think, a couple of applets here. I move around a little bit on this screen, so hopefully that doesn't bother you. But I'm going to kind of summarize what we've done so far, and then we'll kind of use this to get into this idea of a coterminal angle. All right, so basically, what we learned so far is that we're doing angles in standard position. So first of all, if you're going counterclockwise, it's a positive angle. And the key thing is to know it goes 90, 180, 270, and then, of course, all the way around the circle is 360. Okay? But one thing happens on angles, and this is necessary because of physics applications and graphing and so forth. Angles need to go on forever. Okay? They don't need to stop at 360. You usually just learn about circles early in school. So we can continue to go on. So if I do 2 laps around the circle, that's 720 degrees, because 360 times 2 is 720. And then I can go indefinitely. So that would be an example of a 1080 degree angle. That's 3 laps around the circle and so forth. Okay. The other thing is we also did this. It works the same way with negative angles. So if you go clockwise, then your angle is negative. Okay. So 1 lap that way is negative 360. But again, the same thing applies. You can make infinite laps around the circle. So you have that and so forth. This is kind of cool. I like doing this, okay? And it'll just tell you what the angle is. So that's what a negative 2,861 degree angle would look like, all right? Okay, so that may be a new concept to you. Okay, so now we move on to this section here. I'll talk about coterminal angles. And again, I just showed you on that applet that 720 just means 2 laps. Negative 720 is 2 laps clockwise and so forth. Now, what we mean by a coterminal angle, we say 2 angles are coterminal if they have the same initial side. That just means they start at the same point. Then they have the same terminal sides. That means they end at the same point. So this diagram here would illustrate that well. This one is a 120 degree angle. And if you go clockwise, that's a negative 240 degree angles. Those angles are not equal. They're coterminal. And it just means they start at the same point and they end at the same point like that. Okay, so every angle will have an infinite number of angles that are coterminal to it, because you can go around the circle as many times as you want to. I mean, if I did this, if I went another lap around, that would be a coterminal angle to 120 degrees. So that's the idea. One thing I want you to notice on this is if I take 120 degrees and add really the absolute value of negative 240. Notice that 120 plus 240 is 360, okay? And that should make sense to you because you've made a journey all the way around the circle, partially in one direction and then the rest in the other. Okay, so we're going to basically do some sketches of these things, and then we're going to find coterminal angles on this. Okay, so first of all, we're going to go ahead, let's set up how we would draw this angle, and we're just going to start by doing the x-axis. Now you can use your calculator on this. It's just as easy to use a calculator on this because the numbers might get pretty big and everything. So really all you do on this, I'll show you two ways to figure out how to graph this. This is obviously bigger than 360, so it's more than one lap around the circle. So one way you could do this is, okay, you could subtract off 360, and then that would give you one lap. Okay, so, and I'm not going to write this down as we go. So that would give 640. Okay, so we've gone around the circle one time. Then if we do 640 minus 360, so I'm going to do that on the calculator again, then I end up with 280. Okay, so what I've done is I've done a second lap around the circle, but I ended up with an angle of 280 degrees. So what we'd end up doing on this then, as far as graphing this out, you would start in, the way you're doing in standard position. It's a positive angle, so it's counterclockwise, so we would go like this. So I'm going to say, okay, there's my first lap. There's my second lap. Now do 280 more. So you got 90, 180, 270, and then 10 degrees more would give you what that angle looks like. Okay, and then be sure you put the little arrow on there to indicate the direction. So that's actually how you would draw that. Now, I would never ask a student to draw a 1,000,000-degree angle. I mean, no more than about 2 or 3 laps around the circle. You're just trying to get the idea of what this means anyway. Okay, now if we do the smallest positive coterminal angle, well, that is going to be 280 degrees, because if I take 280 and subtract 360 on my calculator, then I start getting into the negative angles. So that's as far down as you can go. Okay, next one we'll do the same idea. And let's kind of get this graph going on this one. Okay, and again, we'll use the calculator to kind of help us on this. So I'm going to start this way, and then I'll go back through in just a minute and show you kind of a different way you could do these problems. So what I'm going to do on this is I'm going to add 360. Because I start with a negative angle, I want to change it to, again, to a positive coterminal angle. Again, we can just use the calculator if you want to on that. You can do it in your head, or at the side of your paper if you want to. So, whoops, wrong thing there. So I'm going to do negative 540 and plus 360. And we still have a negative angle. So that's negative 180. So that's our first trip around the circle. So far what we have is this. We start there. We're going to go clockwise, one lap around the circle like that. Now what you can do is you can go ahead and just go a negative 180 more. So I'm going to go ahead and just crunch this out halfway around the circle like that. So that's where you end up on that. So a negative 540 degree angle is one lap clockwise and negative 180 more. All right, now what I need to do to get the positive coterminal angle is I just add 360 to it again. Now I'm into the positive numbers. So that coterminal angle would be 180 degrees. Okay, like that. Okay? All right, any questions on that? Okay, so I want to show you one other thing you can do on this. 1,000 degrees, this is the way I usually do this, is I just take 1,000 and I divide by 360. Okay, and here's what I'll end up having on this. This is a good thing to write down if you need to. So if you do 1,000 divided by 360, you get 2.7, and then you got repeating sevens. Well, what do you think the 2 means? That means that you're doing 2 laps. And how about the 0.7? That's kind of like a percentage of what's left over. So if you were to go 360 times 0.7 on your calculator, and this is what I do. I just subtract 2. Now I just take that 0.7 and I multiply it by 360, and that'll tell you what that leftover positive angle is. Okay, so that gives you 280 degrees. So what I've done is this tells you the 2 laps. So I did, the 2 laps, and then I've got the 280 more. So that's a real easy way to do that. I'll do the same thing. Here's another thing you could do like this. Say you had an angle like 25,621 degrees. Okay, well, what you would do is you just divide by 360. Okay, what is the significance of 71? That would be 71 laps counterclockwise. Then just take that decimal part. Whoops, I didn't do that right. Oh, I didn't subtract right on that. I need to just get the decimal part on that. And I really screwed that up. So anyway, what you're left over with here is 0.16, 9, and then 4, then a bunch of repeating 4s. Then if I multiply by 360, then I'll get the leftover angle. So that leftover angle is about 61 degrees. Okay, that's the idea. Okay, you can do this, the negative one, the same way. You can go 540, you don't have to worry about the negative, divide by 360. What that does is it gives this. That's 1 lap and half a lap. Now, don't worry about the negative because that just tells you that you're going clockwise. That's all that says. Okay. Okay. All right. Let's move on. And I'm going to go ahead and let you work on these two problems. And I'd like you to do these yourself too, so that you can see that you're getting everything down and make corrections as we go. So I'm going to go ahead and pause here. When you're done, just resume the recording, and then you can check. All right, so this is what I've come up with on these things then. So just to begin with, I didn't do the graph yet, but what I would do on this 1250 is I just did this. I do this on the calculator, 1250 divided by 360, which gives this. That means 3 laps. That's positive, so counterclockwise. And then I take the decimal part and multiply by 360. So I just do this on my calculator in just a couple of quick steps. I do this. There's my 3 laps. Then I subtract 3 to get the decimal part on the calculator. Then I multiply that by 360. So that gives me that leftover coterminal angle of 170. So then for your graph, what you would do is you would start the positive x-axis, and then go like this. You would have to do 3 laps. So I'm going to go like this. So there's 1, 2, 3, and then 170 more. So 170 more would be in quadrant 2. So that's roughly what your graph should look like, is like that. Okay. The next one is a negative angle, so it's clockwise. So you would start like this. Again, I did 450 divided by 360 on the calculator, and I got 1.25, which means 1 lap and 90 degrees more. So you're just doing 25% of 360, which is 90. Okay, so when you draw this, you just go like this. Do my 1 lap. Okay, then I do 90 more, and then the angle terminates on the y-axis like that. So that would be how you'd want to draw that angle. All right, now as far as doing the smallest positive coterminal angle, now this, you got to do this. You can go through and add 360, and then notice that's still negative. So if I add 360 to it again, then what I have is I have 270 degrees. So the answer to that problem, the smallest positive coterminal angle, is 270. Okay, that's the idea. All right, and just one thing I want to mention on this a little bit. This is worth writing down. So on this first one, all you're really doing by doing this division is when you get 3 laps, you're just saying, okay, 3 times 360 is 3 laps. Then I have the leftover 170 degrees. Okay, we're just breaking it up like that, where that gives you the laps, and then that's the extra angle that you're left over with, like that. And then also on the negative 450, what we have on that is we really have 1 lap around clockwise, like that, and then plus negative 90 like that. All right, so that's all you're doing with that calculation. All right, so any issues with that? Okay, so it should be okay with that. Okay, so let's see. I'm going to now do a little bit more with just finding multiple coterminal angles. Now, really all you got to do is if I give you an angle and I want you to give me, we're going to give 2 positive and 2 negative coterminal angles. Well, all you do is you just do this, okay? You go, remember, coterminal angles are off by 360 degrees. Most of this you just kind of do on your calculator. So you have 800 and then minus 360, and that gives 440 degrees. So 440 degrees is an example of a coterminal angle. Okay, then I can take 440 minus 360, and then that will give me another number that's positive, so this angle would also be coterminal. So that would be 80 degrees. Okay, so therefore we would have that. All right. Okay, now when we do negative angles, well, okay, what we do on this is we just keep subtracting. So now we do the 80 minus 360. Just do it on the calculator as you go. So 80 minus 360 is negative 280. So that would be a negative coterminal angle. And then do it again. And that would give you the other negative coterminal angle like that. All right, so that's how you do that. Okay, just use your calculator. It's just adding 360, subtracting 360, nothing to it. Okay, let's see. So go ahead and try this one. You can just do this on the calculator. I'll give you a few minutes to do that, and come back and when you're done, start the video to see if you did it right. Okay, so if you did this correctly, this is what you should have got. Okay, just add 360 to the negative angle, you get 310. Add 360 to 310, you get 670. To get your negative angle, subtract 360, so you get negative 410, negative 770. Okay. All right, so I'm going to open up this applet. The internet has got tons of applets. I wish they had this kind of stuff when I was a student, because visually you can show students and make things really clear with a lot of these things that are called applets that teachers and computer programmers put together. So we're doing coterminal angles, so we know what that is. So if you have a 51-degree angle, what we're going to do is we're going to slide this into its coterminal. All we do is we make it terminate at the same point. Now those two angles are coterminal, so you have 51 and 411. Then you take another lap around the circle. Now they're coterminal. That's just trying to show you that they start at the same point, they end at the same point. And of course, it's the same thing for negative angles. All right. Okay. Real simple, but that's kind of a neat thing to show students. All right. So let's see. Got one last thing that we want to kind of look at. I guess a couple of things we want to look at. This one, we're going to look at how you further subdivide. So whenever you have an angle, you can, 1 degree can go down to further increments, like fractional parts of a degree. So the key thing that you want to know is 1 degree is the same as 60 minutes. Okay, we call minutes is a unit of an angle, is the way that goes. And then every time you have a minute, it gets further subdivided into seconds. Minutes are represented with apostrophe. Seconds with quotation marks. Okay, so if you had this, that would be read 30 degrees, 15 minutes, 32 seconds. So it's 30 degrees and a fractional part of a degree is what that means. The other thing that you want to know is 1 degree is 3,600 seconds. Now where that comes from is if you just multiply 60 times, whoops, not degrees, if you take 60 times 60, you get 3,600. So the idea is 60 minutes, 60 seconds, multiply the two things together, and then you're going to get 3,600 seconds make up a degree. So this is kind of the key thing that you want to make sure that you know. All right, so it's just basically a decimal part. Surveying, a lot of times surveyors use this a lot. Surveyors tend to, they mark off things on land, and then they use an angle measuring device, I think it's called a secant, and they can measure angles. And if they're getting it real accurate, they try to get that down into fractional increments. Okay, one other thing that I think you should know is this. So basically, 1 degree is 60 minutes. Therefore, a half of a degree is what? Yeah, 30 minutes. That's worth knowing. Another thing would be a fourth of a degree would be 15 minutes. And 3/4 of a degree would be 45 minutes. The reason it's kind of good to know that is for estimation. And like when you go down to this example right here, you should be able to do this in your head. That's got 30 minutes, so that's just half a degree. So the answer to that is 12.5 degrees. Now what you're going to do, and you're going to do most of this on your calculator, and you'll have to use your calculator for a lot of this, otherwise it'd just be, tremendously big, long division problems. So what you do is you just take the 30 and you divide it by 60, because there's 60 minutes in a degree. So what you do is just go on your calculator. You can go 12 degrees plus 30/60ths of another degree. So you can just go 12 plus 30 over 60. Obviously, you can do this one in your head, but you can do that kind of methodology to get this every time. Okay? Right? So the next one, the thing about this, students are really bad about this sometimes. Don't put the negative in your calculator. You can type it in your calculator like this. You could have negative parentheses, then you would have 105 degrees. Now, the 48 is minutes, so you say 48/60ths of a degree is what that means. And then when you go to the seconds, my pen sprung a leak again almost, it looks like. That's crazy. Well, it's okay, so I guess it's fixed. Okay, so what I do now is I do 32 out of 3,600. You don't do, that's out of a degree now, so you're doing that. So the way I do this on my calculator, you don't have to put that negative in, because all that tells you is the answer is negative anyway, see. So I just go 105 plus 48 over 60, and then plus 32 over 3,600, and then I'll have the decimal. Okay, and then you can round that off, so that's negative 105.808. Now I'm going to round that to 81. Okay, and round it off to whatever you want to round that off to, or what you're requested to round that off to. So that's it. Now the thing that I want you to notice on this too is that's 48. If you notice this, 48 minutes should be a little bit bigger than 45. Therefore, it's a little bit bigger than 3/4. 3/4 is 75% or 0.75. So that 0.81 makes a lot of sense. I like to get students to think about their answers. Think about if it's logical and it makes sense, okay, instead of just getting an answer and moving on. Okay, now we're going to do this the other way. We can go from degrees to, or decimal to degrees, minutes, and seconds. Well, first of all, on this, 0.75 is 3/4. So we said 3/4 of that was 45. This is one that you could do in your head and just write your answer as 12 degrees, and then it would be 45 minutes, so you put the minute mark on there, okay? Now, the way you can do this, if you can't do that in your head, which would explain most of the time, is take the decimal part and just take your calculator if you need to and multiply that by 60, 60. So if you do that, that would give you what you need anyway. So I'll show you on that. 0.75 times 60 is going to be 45 degrees. Okay, so that's what way we're going to do these problems then. Okay, this one, just take the degree part and then write that. It's negative, so make sure you have that. So what you need to do is take the decimal part, and you want to do this like this. Okay, multiply that by 60. So we go 0.254 times 60, and that will give me 15.24, and that's given us in minutes. Now what you do there is this part would be the minutes, so you would want to write that as 15 minutes. All right, now what you do is you still got a decimal, so you want to take that piece, the 0.24, and you want to multiply that by 60 again, and then you're going to be into the realm of seconds there. Okay, so I'll do that on the calculator. If I do 0.24 times 60, that's going to give 14.4. All right, so that's 14.4 seconds, and you can round that off if you want to 14 seconds like that. All right, so that would be how you get those two answers on that problem. Just use your calculator, right? Okay, all right, so let's go to this next page, and let's see, I'm going to have you do these yourself. just go ahead and do this example 5 and then that example 6. Use your calculator, and then to finish up the section, I want to show you how you can do this more automatically on a TI 84, 83 type of calculator. Okay. Okay, so you can kind of check over and see if you got these answers and see if you did something wrong. Go through and think about what you did wrong. So again, I just did all these on the calculator. This one I just do in pretty much one big step. So 5 plus 10 over 60 gives this, and then I just rounded that off to 5.17 and round it off to whatever you want to. This one, again, don't put the negative in your calculator. Notice on here I didn't put the negative. If I put a negative there, it would give something totally different, and it wouldn't be correct. Okay, so it's negative 215 and some fractional part left over. So it goes like that. So I put that in and got 215.31. Okay, a couple of things I want you to notice on this for estimation. That's 10, remember, half a degree is 30 minutes. Okay, which would be 0.5 degree. So if that's 10, that's less than half, that's less than 30, so that decimal part's going to be less than 0.5. Okay, always kind of think about that and use that, help you to get that down for estimation. Okay, what I did on the next one is it's 12 degrees, just write down the 12 degrees, and then 0.5 times 60 is 30 minutes, so that would be your answer. This one, you have the degrees already, so just write that down. Take the 0.626, if you multiply that by 60, you get 37.56. So the 37 is your minutes. The leftover decimal needs to be multiplied by 60 again, and that gives you 33.6 seconds like that. All right, so to finish this up, now to me, that's the best way to do these conversions, because this way you remember the connections. Your calculator can do this automatically, and you're more than welcome to do it that way if you want to. But a lot of times it's just as easy to do it the way I just taught you. So you can review. I'm just going to do one example kind of each thing on here. So I'm going to, and you probably should write this down. Let me just make up, let's say we have 125 degrees, 15 minutes, 36 seconds. Okay, so let me show you how to do this. And what you need, the first thing you got to do is find this apps button. On your calculator, you have an apps button right here, and above that it'll say angle. To activate the angle menu, you go second apps. So you go second apps, and then that's where you're going to find this menu. This is going to be basically on there, so that's your degree, and then that right there is your minutes. Now the seconds are not on there. I have no idea why they made these calculators this way. It doesn't make any sense to me at all. This is where the seconds is. So the second, you got to go alpha. You press the alpha button, and then you press the plus button. Okay, that's usually in a different color like green. So if I go alpha plus, that's where I'm going to find that particular thing then. Okay, all right. So you can go like this then. So what I'm going to do is put this in. We just go 125 degrees. Then you go second apps. Okay, you want to get the degree, so press enter. Then put in the 15. Then go second apps, right there. Go down to option 2, press enter. That's the minutes. Now put in the 36. Then you go alpha. Not that. Not that. Okay, shoot. Let me do that again. Okay. All right, so I got to start over again. Sometimes you can't see what the heck I'm doing. Okay, so I go like this, 125 degrees, 15, second apps, and option 2. Okay, then I go 36. I'll do it right this time. Alpha plus. Okay, then you just press enter. Now there it is. So that answer is 125.26. Now, to me, it's just as easy to do it the way I taught you the first place, because you do it this way, you got to know where all the symbols are, and to me, it's faster to not even do it this way on the calculator, but you're more than welcome to do that if you want to. Okay, the other thing I want to mention is the DMS that you'll find in the menu. What that does is that converts, that stands for to convert to degree, minute, seconds. DMS is degree minute second. So this is actually really slick the way this works. So if you had something like 120.32 degrees, like this, what you would do is you would just go 120.32. Then again, you want to go second apse, like that. And then you go down to DMS. That's going to convert it for you. Press enter. It'll come up on the screen. Press enter one more time. And then there's your answer. Okay, so that's giving you 120 degrees, 19 minutes, 12 seconds, like that. Okay, so I just wanted to show you how to do that. That's kind of a nice thing to learn how to do. You can do those either way. All right, so that will kind of wrap up what you need to know on the section on here. So this will be the first part, and then we'll be looking a little bit later at a few other things as well. All right, hope this helped you to learn how the angles work.